Okay, here's a problem that came across my desk. What is 1/6 plus 1/2? So we have a rule for adding or subtracting fractions, also applies to radicals, which says we can only add or subtract like fractions, and that means fractions that have the same denominator. So we need to find the LCD. Now, a lot of you can just look at this and go, oh, the LCD is 6, and that's great, but what do the rest of us do? If we can't just look at it and know that the LCD is 6, how can we find the LCD? And this is where we're going to bring back a technique from another video called prime factorization. And as I said in that video, we use prime factorization to do a great many things. In this case, we're going to use it to find an LCD. So 6 is 2 times 3, and I'm going to circle both of those because they're prime. 2 is already prime. So now this is a little bit strange. The LCD, or least common denominator, is the LCM, or least common multiple, of the denominators. So we're going to use these prime factors over here to build the least common multiple of the denominators. And the way you do that is you use every factor that occurs the most number of times it occurs for any one number. I know that's a mouthful, but just bear with me. It makes more sense with examples. So for example, is there a prime factor of 2? Yes. How many 2's does the first number have? 1. How many 2's does the second number have? 1. What's the most? 1 or 1? Not what's the total. What's the most? 1 or 1. The most 2's that either number has is 1, 2. So I'm going to use 1 factor of 2. Okay, are there any other prime factors that occur? Yes, a 3 occurs. How many? Well, the first number has 1 factor of 3. The second number has no factors of 3. What's the most? 1 or none? 1 is the most. So I'm going to use 1 factor of 3. And then I multiply these together to get my LCD, which is 6. So my LCD is 6. And I know that was kind of obvious to some people from the beginning, but that's okay. These get a lot more complicated, and we can use that same technique when we're doing algebraic fractions in high school. So it's really important to know, where am I getting that LCD of 6? Where did that come from? The next thing I have to do is rewrite each fraction, each of the original fractions, with the new denominator. Well, the first fraction already had the LCD, so it's just going to stay the same, right? The second fraction, on the other hand, that one I need to raise. Let me get out my blue here. I need to raise from a denominator of 2 to a denominator of 6. Raising is the inverse of reducing, and so we use multiplication. What do I have to multiply? 2 times what? 2 times 3 makes 6. So I also have to multiply the numerator the same way. As long as I multiply my denominator and my numerator the same way, then the overall value of the fraction stays the same. So my numerator, 1 times 3, is now 3. So 1/2 has been raised to 3/6. And so now the next thing I have to do is rewrite this whole addition problem with my new LCD fractions. The first one actually ended up staying the same, and the second one is now 3/6. Okay, now the easy part, to actually add. I just add straight across the top, and the denominator stays the same. Now we have one more step to do, and that's true for any fraction operation that we do. After we do any kind of fraction operation, we should reduce. Okay, so we need to reduce the 4/6, and both of these reduced by a factor of 2. 4 divided by 2 is 2, and 6 divided by 2 is 3. And so this whole thing becomes 2/3. Let me show another way to do this reducing of the 4/6, and that is again with prime factorization. We already did the prime factorization of 6, but it's quick. I'm just going to write it again. And so here's how we use prime factorization to reduce. I'm going to cancel out any factors, any prime factors that they have in common. They both have a 2, so I'm going to cancel it out. That's it. This only has a 2, this only has a 3, and that is what is left in our answer. The 4 reduced to a 2, and the 6 reduced to a 3. Now that's a very simple example, but again, this same technique works on much more complicated examples, and that's why it's important to know it. If you have a math problem that you would like me to demonstrate, put it in the comments and I will. Hope that helps.